how we do this, how we create it, what we're doing, and how you can get involved, which is very important for a lot of people. Some background, some numbers. This is the size of the Linux kernel right now. As of the 3.10 kernel release, which happened about 1 month ago, almost 17 million lines of code, 43,000 files. It's a huge, huge body of code. Very large. It keeps growing at a pretty constant rate. That's how big it is. It's very large. But the more interesting thing is how big is our community? This is the last year's worth of development. 3,000 developers, at least 450 companies. I say at least because I try and count them, some I miss. This is the largest software engineering project ever in the history of computing. And these numbers keep going up. About 2 years ago, we cracked the 2,000 people boundary, and we're about like 300 companies. We keep getting bigger, which is really amazing if you think about it. This is how big this is. So, this is our rate of change last year, from a year ago till today. 10,000 lines removed, added, 6,000 removed, 2,000 modified. That's a pretty good number for a project, right? Until you realize this. Wait, it gets worse. We're going faster. So what we're used to, the rate of change we had last year, is faster this year. 3 years ago, it's faster this year. But this is an interesting number. For the past year, this is what we did 24 hours a day, 7 days a week. That fast. A year ago, we were going about 6 changes an hour. About 8 years ago, we were going 3 changes an hour, and we all thought that was too fast. This is very, very fast. And these changes are not just in the drivers, and not just in the architecture specific. These changes are flat across the whole kernel. The core of the kernel is 5% of all the code. 5% of these changes are in the core kernel. The drivers is about 55%. 55% of the changes are in the drivers. It's flat across the whole thing. So the old software engineering model of if it's not broken, don't touch it, we keep breaking it. We keep changing every single day. And we change all the time because the world changes. If the world is constantly changing, if we stop changing, Linux is dead. We have to keep moving. This is why we do this. And that's for the year. The last release we did, the fastest we've ever done. I say it's scary a lot. That's scary. That's really fast. That's a lot of changes. You cannot keep up with this if you do not pay attention. What this means is if you are trying to keep something out of the kernel and develop along the side, think it's like out of tree drivers, out of tree hardware, you cannot catch up to us. We will pass you by and it just will not work out. These rate of changes are better, faster, and the size of our project is larger than anybody else. Any other operating system, any other company cannot keep up with us. And because of that, we've taken up with the world. It's kind of funny. So how do we do this? 2 big things we do this to stay sane. We have time-based releases, and we have incremental changes. And these 2 things I'll talk about. So about 8 years ago, we said, let's do a release every 2 to 3 months. And we have, exactly. 2 3/4 months is our average for the past 8 years. It's regular, it's clockwork. And it's a good thing, it's short. It's really short. So if you miss getting something into this kernel, you know, oh, 3 months later I can get it in. So it's very good, it's very predictable. People can build products on it. They can plan their release cycles on it. It's very, very predictable. And that's good. People like predictability, especially when they're using this for companies. So how do we do this? So Linus does a release. I'll pick 3.1 as a number. Then 2 weeks, for 2 weeks, all the developers throw things at Linus. And I'll talk a little bit more about that. And then he does release candidate 1. Release candidate 1 is great. Everybody who, we kind of forgot that there was a release window, send some more stuff, so he does release candidate 2 a week later. And then a week later, 3, 4, 5, 6, 7, 8. And then until it's bug fixes only. We start doing bug fix, bug fix, bug fix. And then he does a new release after 3 months, and then we start over again. This is what we do. This happens every 3 months, and this is how we do development, how we do releases. We realized this about, 8 years ago, that we needed something between those 3 months. What happens if there's bugs found? So we made something called a stable release. So I'm in charge of the stable kernel releases. So Linus does a release, I take that, and then I do about a release every week. So I'll do 3.1.1, .2, .3, .4, and so on down the line. The rules for this is the patches have to be in Linus's tree. And that's really, really important. We don't want these branches to ever to diverge. We don't want the stable tree to get things that Linus doesn't have. And we have a real strict list of things we'll accept. Bug fixes only, maybe a few device IDs, but no new features. We'll take some performance, speed ups and stuff like that. That's how things work. And then another important thing is I throw that away. I drop it on the floor and run away, like when Linus does their new release. And that's very, very good. It makes it so I don't have to keep lots and lots of kernels going at once. That was working out well for a while, and then we found out that people like to build products on Linux. So we wanted to make something that was more stable for them. So we made something called a long-term kernel. So long-term kernels, I pick one a year, and I'll maintain it for 2 years. After 2 years, the number of changes that go into those kernels falls off. So after 2 years, you shouldn't be using that anyway. 3.0 kernels right now long-term, 3.4 is long-term, and I guess I get to announce now today, the 3.10 will be the next long-term kernel. And people build products on this. There's an LTSI project from the Linux Foundation that a lot of people are picking up. Yocto's picking it up, Lenaro's picking it up, Android's picking it up, or basing it on there. So you can rely on that kernel to be maintained by the community for 2 years. Security fixes, bug fixes. It's a really good thing. A lot of people are doing this. If anybody has questions, please feel free to ask them. So, that's how we do releases. Constantly do releases, maintain these for 2 years. Linus comes out with a new one every 3 months. That's it. So, what do? How do we make a change? So, let's talk about this. So we have developers. We had almost 3,000 developers, right? And they make a change to the kernel. They want to write a new driver, they want to fix a bug, they do something. So they take that and they send the patch. I'll show you about patches in a minute. And they send it through email to the maintainer of that file. So the maintainer is, we have about 700 of these people listed. They maintain like a subsystem like USB, which I maintain, or networking, which David Miller, or such, or just a file, just a specific file. Lots of people own individual drivers, things like that. About 700 of those. They look at it, they review it, they say yes, no, it's good or not. And if it's good, then they'll pass it on. So let's look at what a change looks like. This is a change. So a patch is one, we have to break all our changes in the Linux kernel up into individual pieces. Like your old math professor said, show your work. I want to see every single step along the way. You can't just say, rewrite the scheduler. You have to say, change this, change this, change this. And here's one example of one thing. It's a patch written by Robert. There's the author at the top. The subject says it's USB on the go. A little description, and then there's some signed off bys. So Robert, when he does this patch, he says, I agree that this is my work. And I'll talk about that in a minute. David Kernel, who is the maintainer of that, said, looks good, he'll acknowledge it. And he sends it off to me, I grab it, and I put my name on it. That's an old one, I don't work for SUSE anymore. And then there's the change. It changed to, we actually look at X before we reference it, so it fixes the bug. And that's it, one tiny little thing. So these are what happen constantly, 9 of them an hour. This is the change. So one thing about this is, you see 3 people's names associated with this 1 or 2 lines. In the kernel, you can look at those 17 million lines of code and say, who wrote this line? Who reviewed this line? You can trace every single line of the Linux kernel back to at least 2 people who reviewed it. It's the best audited body of code out there. It's crazy. Lots of companies look at this and they wish that their internal companies, their internal developers would do this. So let's say we're using Git now. So you can track every single line of kernel to who was responsible for it. So the signed off by, if there's a problem with this, somebody can say, hey look, there's a bug here. And I'll say, oh, I'll blame Greg and David and Robert. But that's good, so it's personally responsible for me, and you put your name on it. It's not a company's name, it's an individual's responsibility, which is a very powerful thing. Both it's good for recognition, it's also good for making sure you do good quality work. So that's a patch. So a little bit about signed off by. So signed off by is something we came up with a number of years ago, and it basically means this. You created it, or it was based on something somebody else created with a proper license, which means it's compatible with the GPL version 2, or somebody else provided it to me, and it's public. Public is important, and it's not anonymous. It has to be with the real person's name. Or I have to not know you're anonymous. We accidentally take things anonymously, but we fix that later. So I can't know that, I have to know who's behind every line of code. That's what we do. So every bit of code in the kernel uses this. A number of other projects are starting to use this as well. I think Git uses this, and there's a few others as well. It's a good, nice little, concise, legal thing. So, all right, so let's go back. So then, those file, the drivers, it went to those 700 people, and then they take that, and then they send it off to the subsystem maintainers. Subsystem is like USB, networking, PCI. I currently maintain the serial layer, the USB layer, the driver core, and a few other weird things. So I'm one of those people. We have about 100 subsystem maintainers we're running about now. So all these people send those code up to them, and every one of those, they have a public tree. They have a public Git tree that is pulled every single night from, in Australia, there's a developer, Stephen Rothwell, pulls those together into the Linux Next tree. That's at the top. He checks all the builds and all the architectures, he checks that the merges work properly, and he sends us bug reports. He says, oh look, the networking stack conflicted with a change you made in the USB stack, guys work it out. And he does that, and he merges it every single weekday and tests it and builds it. If you want to see what the next kernel is going to be, not the current one, test Linux Next. If that's the best thing you can do, test it and let us know if there's any problems. Because that's, all of us can test our own individual trees, but we can't test everything together. Very important. And then there's Andrew Morton, who sits off on the side and he just scoops up stuff for subsystems that don't have maintainers. There's a lot of that. He picks patches that we forgot or I dropped, whatnot, and he pulls them, and then that goes in Linux Next as well. Andrew does a lot of work that way. It's really good. He's the only person that reads all of the Linux kernel mailing list. Everybody else, we all filter it. So that's how we work. Everything gets into there, and then when Linus opens the merge window, like I talked about, we all send it to Linus. Now, Linus doesn't pull it directly. We have to explicitly say, take this, take this. And that's important, because sometimes stuff in Linux Next is not working. Like a couple kernel releases ago, the TTY layer, we had some real big bugs. It would not be good if Linus just pulled it in. So I had to wait a whole kernel release cycle. It's only 3 months. We were okay with that because we knew it was going to be a short term, and he didn't pull that. So we all throw him to Linus, he sucks them in, and then the development cycle goes on. And that's how we work. Linux Next every day, Linus every 2 months, 3 months, Andrew, so 3,000, 700, 100, up to Linus. That's what we do. Make sense? Questions? You guys are quiet. All right, I'll move on. I got more stuff. So let's look at what we did last year. This is always fun, just to see where a lot of changes are happening in the kernel. So last year, this is quantity, not quality. Anyway, I know these guys are great. So this is what one developer did last year, Hartley. 1,900 patches were accepted. Now think about that for a second. Our rate of change is 9 patches an hour, right? That is the patches accepted. That is not the patches submitted to us. So we review, we reject a lot, they go through review cycles, they get rewritten, they get fixed, whatnot. The amount of code that's coming at us as developers is like double to triple that rate. These are the ones that have been accepted. So Hartley's, he's been cleaning up the COMD subsystem. That's the data acquisition drivers. He works for a tiny company that makes some engraving systems. They need that for Linux. He's been cleaning up the code like crazy, doing a very, very good job. Good quality. Alviro, he's the file system, the virtual file system layer and the core of the virtual file system. He's been reworking things. Very good stuff. Mark Brown does embedded sound development, so he's been doing a lot of work. Shashin, he is the ARM platform maintainer for one of the chips. I'm not sure which one. So a bunch of work has gone into there. Hans does video for Linux, a lot of media developed drivers. Alex came in out of nowhere because of the remote disk driver or remote block device tree finally got pulled in. That was something that's been sitting outside of the kernel for a long time. It got sucked in the past year, so he showed up there. Johannes, Intel wireless drivers. So these are, this shows like a lot of places where one bit of the kernel is changing a lot. Takashi's sound, Alexel is an example of somebody who's just doing janitorial work. He goes through the kernel, fixes up bugs, cleans things, spelling fixes sometimes. People send us patches, that's good. But he's fixing up lots of little tiny bugs everywhere around the kernel. And that's a really good thing. Alexel does a really good job, and we have a number of other people to do that. So you can do janitorial work in the kernel and still do a lot of it and get good recognition. And then Jingo does the backlight and frame buffer drivers for some embedded systems. So that was the quantity that happened. So then I showed the signed off by. So this is the signed off by for the past year. So that's what I do. I read code every day. That's all I do is read code. Somebody said, David Miller, so David Miller does networking. David compared the job of a subsystem maintainer to be like an editor for a book company. We read things, we tell you what to do, the writers what to do, we tell them how to revise things, and we're editors. We push back, we accept things, and every once in a while we get to go work on our own little project. But we're editors, and that's what we do. So I do a lot of USB staging drivers, driver core. David, networking, Maro, video for Linux. John, wireless networking. Mark, embedded sound. Linus does everything. This is something interesting. See, Linus isn't sign off by every patch. You notice how he pulls patch trees from somebody? And that's because we work on a web of trust. Linus trusts some of us to get things right. I trust things from other developers. So I will pull some developers' trees, and I just assume that it's right. And I don't assume, when I talk about trust, we don't assume that you got it right all the time. I assume that if there's a problem, you'll be there to fix it. And that's really important. When you're submitting something big to the Linux kernel to start with, I want to make sure you're going to be around there to fix the problems. We've had some very big problems in the past. There's one large networking feature that went in a number of years ago. David Miller accepted it. The next day, that email address disappeared from the web. And it took him about a year to fix all the problems. So if I accept your code as a maintainer, I have to know that I am now responsible for this, so I want to make sure you're going to be there. So if you're trying to submit something new for the first time, there's going to be a lot of pushback to start with because I want to make sure you're going to be here to fix it. That's one thing that makes things harder for us, but we do it for a reason. Andrew Morton, lots of patches, Mark Brown, embedded sound, Hartley, comedy. So Hartley, one guy, he didn't sign off anybody else's patches. He did it all himself, and he still made the top 10. John, wireless, Daniel, DRM layer, video layer, Johannes, another wireless driver. So these are areas of the kernel that are getting a lot of development. Tells you what's going on. So, any questions? All right. So now, who's paying for this work? This is fun. I've been tracking this for about 6 years now. And for the past 6 years, it's been very constant that about 15 to 20% of the work on the Linux kernel is done by people that are not getting paid for it. It's been a pretty constant number. These are amateurs, number 1, and unknown individuals, number 6. Amateurs are people we know that they're not working for somebody. Unknown is I don't know who you're working for. But all those unknown people, they're not doing any more than 5 patches. Just like a one-off here and then. The problem with Linux kernel development is if you start getting a few patches in the kernel, you get a job. You will be hired. I mean, it is really, really hard if you're a kernel developer not to get hired. We need them. There's lots and lots of companies using Linux. So if you do any number of contributions, you'll start getting emails from Google and Intel and lots of people wanting to give you jobs. So if you're a student in school, start doing some kernel work today, we can get you hired tomorrow. I mean it, we need those developers. And I talk to a lot of students, and it's really important. Because it shows you're working in a community. As an employer, if I see that you're working in a community, you can communicate on email, you're not crazy, I can hire you. I mean, that's a good thing. That's a really good thing to work in open source development if you want to get a job. You don't need a resume anymore, your code is your resume, it's all public. It's a really good thing. So here's who's funding it. Red Hat, Intel, Lenoro's come up a lot. TI, Vision Engraving, that's Hartley, the one guy, number 7. So the one guy, for one company, did that much work. So for companies not to be able to contribute to the kernel, like, oh, it's too hard, one guy, it's not hard. SUSE, number 8, IBM, Samsung. Samsung's gone up a lot. Pardon me? It's fine, yeah. Samsung, here's some more. Google, consultants. Broadcom. Renesas, Oracle. I don't know what ink tank storage is. And Cisco. So this is 400, those are the people that did that. So the Cisco one is about, I want to say it's like about 300 patches. So anything to that starts dropping off. So that's who's funding this. That's who's contributing this work. Intel, IBM, big ones, Google. The Google stuff is nice. That's their server guys. Their Android guys aren't doing that much. They're doing a little bit. Hey, no, I mean, their stuff has already been merged. It's done. You laugh, it's merged, it's in your phone. The Android guys aren't doing new kernel development these days. The server guys are. Android stuff is done. So it works really well. So it's not a knock on the Google guys. I like them. I hope they like them. Any questions about any companies? Anybody want to know? I've got to pull this somewhere. How about the Android? All the Android code is in the Linux kernel today. It's been there for about a year. Yeah, it's all merged. It's very tiny. It was only 7,000 lines of code. Your serial driver is 3 times that big. I mean, it was not much. It was not very much. They had some interesting things. They had some new features, but it's all merged. It's all there. It's all not going anywhere. They have some new things coming along. Lenoro's trying to help merge a few other things that's coming up for new devices. Different ways to do some process communication, but it's there. You can take stock kernel and run your phone today. So that's been it. Any questions?
How was Microsoft doing?
Microsoft, they're doing well. So let me give you some context here. Last year, Microsoft was in the top 20 of Linux kernel developer contributions. They contribute the hypervisor, the Hyper-V. They run as a virtual machine. You can Linux running on Azure, which is their big cloud platform. The key Microsoft developer that does Linux work came from Novell. I know him, KY, very good guy, and there's a few other people there. And they do a lot of Linux work. I live in Seattle, where Microsoft is. When the Linux Foundation came out with a report last year, said that Microsoft was in the top 20 contributors to Linux kernel. The local paper referenced that old quote by Steve Ballmer that said Linux was a cancer on society. It said, has Microsoft cured cancer? That was the local paper. That was funny. Actually, Seattle has a lot of ex-Microsoft people doing Linux work. It is. There's a lot of Linux jobs. I mean, all the Amazon stuff, Facebook, Google has huge offices, IBM, Valve is doing all Linux work now. They're all ex-Microsoft people. That's great. So, anyway, so Microsoft. Any other questions about companies? Yes?
Did NVIDIA founded after Linus' speech?
Did NVIDIA change after Linus' speech? So what you said?
Did NVIDIA founded after Linus' speech on NVIDIA?
No. So did things change for NVIDIA before or after Linus' speech? The NVIDIA stuff is the NVIDIA Tegra, the embedded stuff, and this is not their video drivers. They have a lot of ARM embedded, well, that's those guys. I talked to them, I know them, they're a totally different division than the video guys. Yeah. I ran into the NVIDIA closed source drivers at Valve. He was sitting in the corner and said, don't talk to me. I know why they do what they do, that's fine. That's fine. So no, it didn't, and Linus is rightly mad at them. So. Nobody asked about canonical. Yeah. Moving on. All right. So, product development. I want to talk about this. If you work for a company, this is your normal product life cycle. If you're doing like new hardware, things like that, time goes on to the right, design, bring up, integration, testing, release. That's a generic thing. I talked to a lot of hardware companies, that works. So ideally, this is where you want to do your work for the kernel. You want to do your kernel, submit your code to the kernel before you integrate it. And it gets accepted, takes about 3 months to get accepted and merged, and then it comes into the Linux kernel before your hardware is released. And people say, no, I can't do that, I can't do that. This is what you have to do. Your competitors are doing it. An example, Intel, like 2 kernel releases ago, we ripped code out of the kernel for a chip that Intel never shipped. It was merged that early, it was accepted that early that nobody realized that the hardware was never even released. Intel is that far ahead of everybody else. They know it, and they are doing really, really well. So this is actually, Intel is like way left. A lot of companies start doing, the problem is if you release your code, your kernel submission, when the hardware is released, you're playing catch up, because it'll take you another 3 to 6 months to get it accepted. By then your hardware guys are working on the next product, and they're already behind, and you're playing catch up and it's just lost. You have to do it like this. And there's a reason why. IBM and Intel have publicly said this. It saves you money and it saves you time. So if you work for a business that says, I can't do this, it's going to cost us too much money or too much time, IBM, Intel, huge companies with lots and lots of money have said it saves them time and money. So for you to ignore them means that they will beat you. I gave this talk to ARM, the ARM developers, and they agreed. I mean, ARM has a problem there. ARM is very, very late. Their hardware comes out, and then they get around to doing the kernel code. And they know they need to work on that. That's why they formed Linaro. Linaro is doing really well, but they have some work to do. Intel is doing really, really well. So you can do this, and you have to do this if your company wants to succeed. Don't want to make it sad, but that's so. How do you get involved? And I'll point to the individuals. The best thing you can do is run the latest release on your machine. That's the best testing you can do. We need that. If you have a problem, let us know. If you wait to a couple releases to go by, to pick it up from a distro or whatnot, we won't remember what we did. Remember, we're doing 9 changes an hour. I can't remember what I did last week, let alone last month. I don't remember what I did yesterday, really. So run the latest kernel. If you have a problem, email us. Our emails are there. We know how, we have tools, we have scripts that point you to the right person. Use it. It's the best thing you can do to get involved. If you want to install a kernel on your machine, there's a whole book that was written. It's free. You can download it. I wrote it, it's okay. I don't get any money for it. So download it. It's actually, a number of years ago, I bought the local, there's a translated copy, it is in Chinese. I bought it in a bookstore here. And when I bought it, my credit card company called my wife at home and said, your card was used to buy a very cheap book in Taiwan. My wife said, yeah, that's my husband. I can travel places, I buy one book and they can flag it. Anyway, it's a free book, it's downloadable online. It tells you how to build a kernel and install it on your machine. It's a little bit out of date, but it's gotten really, really easy these days. A number of distros make this very easy. Fedora, OpenSUSE, Arch, Linux, Debian, all really, really good distros to install your own kernel on. They work really well. Ubuntu has little tweaks to it, but there's good online documentation for doing that. So it can be possible. That's the best thing you can do. Run your own, build your own kernel. So then, how to get involved beyond that? We have a whole how-to. Read that. That's just a link to other documents. It's translated into other languages. There's a Chinese translation, a Japanese translation, a Korean translation. The Japanese were first. 3 hours later, then came Korea and China. The best thing, the Japanese translation, the person who's responsible for that file in Japan, he's a very high-level executive at a very large company. And he likes pointing to his engineers and said, if I can get kernel patches in the kernel, you can. So it's good. So he's in charge. He's a very good guy. And then how we do this, I'll break down in very, very good detail about what I talked about. The development process. It's a really good documentation written by Jonathan Corbett from Linux Weekly News, who I think talked here last year or something. Very good. Very thorough. Read those two things. And then if you have questions beyond that, kernel newbies. There's a very good wiki on there that we document what was in every kernel release. There's a mailing list, which is very good. There's no real dumb questions on there. And there's an IRC channel, too. Lots of people are on the IRC channel. When I'm not traveling, I'm on there. It's a very strange IRC channel. It's very quiet, unless you ask for something. And then you just do it. It's not for talk. There's like 500 people in there and nobody's talking. But then you ask a question and then people pluck up. And then the best thing about that is there's enough people on that IRC channel that if somebody doesn't know the answer to that question, they know how to find those of us who do. So people will say, oh, Greg's over on this channel over here, let me go grab him, something like that. It's a really, really good resource. Very nice. I gave a talk a number of years ago on how to write your very first kernel patch. I think there's a talk after this on how to do that as well. Do that. It's very simple. You can fix a spelling mistake. Submit your patch. A lot of it is how to get the email client to work, how to send it properly, how to document it properly. Usually the hard part is not the part of the patch, it's everything around it. So once you get that down, you can good to go. That's a good talk. And then how about what to do? I talked that Lexel does janitorial tasks. There's a list of janitorial tasks and kernel newbies. There's a whole to-do list. It's kind of a little bit out of date, but it's pretty good. It's a place to start if you don't know where to go, if you don't know what you want to do, but you want to do something. And another really good one is the Linux driver project, which I do. In the kernel itself, there's a to-do file for all these drivers. The staging drivers are really, really bad code. I take anything, it doesn't have to meet the coding style guidelines, it doesn't have to meet the rules. It just has to build, it has to be the proper license. And sometimes that's really hard for some of these projects. So look at that, there's a to-do list. Take something on the list, send a patch. A lot of those is, oh, clean up the white space. Great, a lot of people start there. A number of people have started by cleaning up little tiny things like this, gone on to other things and now have a job. I know at least 10 people that have done that. So it is possible to start with spelling fixes and move on. And that's great, and that's a really good thing. Kind of sad because they go off to jobs and they leave this alone. But I'm happy with that. So, that's good, and I think, yep, oh, my penguin picture. This is taken by a kernel developer, I think, in South America, took a picture. So, questions, comments? Anything? Yes? No.
I've heard that you talked about the ARM portion of the kernel, and then because from what I see, there are lots of trees maintained by these hardware developers, like Texas Instruments maintains their own trees for the OMAD series of processors, or perhaps Arduino also maintains their own trees for their A10 processors or A series of processors. So what's the ecosystem there? Why are they not? Why don't they just work with the Linux kernel maintainers instead of like maintaining their own trees? Why is this happening? Thank you.
Okay, so why does the ARM developer or companies maintain their own trees and not work upstream? If you looked at that list, Lenaro, very high up. Texas Instruments, very high up. Broadcom, very high up. Marvell, no. Qualcomm is interesting. Qualcomm hides their contributions. Only company I've ever seen that. They hide it in weird shell companies. But they all are directly involved in the Linux kernel development process. They have their own trees separate for their products. and they do development before they get into things. Texas Instrument has been merging almost all that back up. Qualcomm has been merging all that back into the tree. The ARM developers community in the past year has done really, really good things. They're now a huge contributor to the kernel. They're integrated properly and they're working well. There's a huge subtree way of sub-maintainers and sub-sub-maintainers, and the developed patches flow to Linux very quickly and very easily now. So that has changed in the past year, year and a half. So they are better, and they're working really well. So they have a ways to go, but a lot of them are doing really good. So they are there. So they know that. They have to, otherwise they can't keep up with that rate of change. Other questions? Concerns? Come on. Yes?
Currently, Linux DPY also can manually display CJC characters, and I want to ask how fast is the version of
So the problem is Linux TTY terminals native console can't do Unicode. They can't do UTF-8. We are changing that by ripping it out. The VT layer, the virtual terminal layer, is being ripped out of the kernel and entirely so that you can do the whole console layer and the whole layer from user space. And it ties user space to the kernel very tightly, a little bit better, but then you get full Unicode support, and you get better font support. And it was a Google Summer of Code project last year, and it's been almost all merged, and the patches are working. There's a few external patches today, but that is almost finished. Because we realized that is a problem, and it was neat that we fixed the problem by ripping code out. So yes, that will be fixed. Yes?
请稍等一下。
I think many of us Taiwanese we think Samsung is our competitor. So would you please tell us about the contribution of Samsung on Linux kernel?
Individually, Samsung only cares about Samsung. That's okay. Intel only cares about Intel. IBM only cares about IBM. What all the individual companies, when they contribute, they only care about their own stuff. Microsoft only cares about Microsoft. And that's good, because the changes that Samsung does benefit you. They do. They did a lot of work on some of the DMA layers, and they did a lot of work on some of the button layers of the kernel, and got it merged. And the memory subsystem Samsung did, I know I work with these developers. I've been traveling to Korea a bunch. And you benefit. So their work makes your devices work better. Makes your chips work better. So that's the way Linux works. Everybody contributes only for what they care about, but it benefits everybody. So don't be afraid of Samsung for the kernel work. Every company is that way. So you shouldn't be afraid of Intel, you shouldn't be afraid of IBM in reference to the kernel work. And that's a really weird thing. So all these companies like Red Hat and SUSE, and we're all competitors, right? I worked for Novell, SUSE, a long time. And it was funny to watch people play the different companies off each other, not realizing that we all knew each other and we all talked on the IRC channel together. So we'd have a customer come to us and say, oh, they said SUSE did this to Red Hat, and Red Hat say, and they'd do the opposite to us, and we'd go, we talk to each other on IRC, we're like, no. But it makes it very hard for managers and vice presidents to realize that Red Hat and SUSE share an engineering team. They do. IBM, Intel, and Samsung share an engineering team. ARM and Intel and HTC, you guys all share engineers on the Linux kernel, and that's okay. That's fine. That's good. It's contributing because you're making your own company's stuff work well, and it benefits everybody. And it's a very, very strange thing. It's a very weird thing to get managers used to get companies used to. Personally, I mean, I never thought I'd be in Taiwan talking about this kind of stuff. Years and years ago when I started programming, it's a very different development model. But we've created something that nobody else has ever been able to create because the model's so different. So don't be afraid of Samsung that way. Be afraid of Samsung for other reasons. They're not engineers. Their engineers are great. You know, they're nice guys. And women. In the front, yes.
You mentioned that.
You mentioned that some of the ARM's contribution wasn't really integrated because they didn't submit it. And you said that eventually they have to catch up. But that, I think, is relying on one assumption that the mainstream will evolve so fast that they cannot catch up, or they right. But we have seen that some of the open source projects couldn't catch up. I mean, couldn't move fast enough, and then lose the edge eventually. For example, Apple's work, a few things like WebKit versus HTML. Okay, so what made you think that Linux will not end up like that? And another thing is, since the kernel is in GPL, why can they keep their contribution hidden? So 2 questions.
Okay, I'll take the second one first, GPL. The Linux kernel license is GPL. That means anything you ship has to be released. That's the law, that's the rule. Binary kernel drivers are illegal. They are. Binary, but not only that, they are technically very, very hard to do. Because that rate of change, it's really, really hard to make a binary kernel driver. You have to spend a lot of money. NVIDIA dumps a lot of money into keeping a binary driver. And also, it's very hard on a technical level, and it's very hard on a moral level. Morally, how are you to say that your tiny driver for your tiny little piece of silicon is somehow more important than the 17 million lines of code that you're relying on? It's just a moral thing. So that's that. All right. So keeping ARM code out of the kernel. They know they can't do that anymore, and they're working really, really hard to do that. They are behind on some of their development, but they're getting better. But how do we know we're going to keep succeeding, right? I look at these numbers every year. I keep these numbers every release. I'm worried that if these numbers start to go down, then we might have a problem. But we are going so fast that these numbers can be cut in half, and we're just going back to the rate of change that we were doing 4 years ago when we were still taking over the world. But because we're doing so well, the thing I worry about, the only thing that can ever hurt Linux is Linux. Seriously, it's up to us to kill the project. So my goal is not to do that. I really worry, all the kernel, all the core people, we really worry about that. We want to make sure it succeeds. We want to make sure it runs on everything. We want to make sure it works for everybody. So we talk to people. That's why I travel so much. That's why I'm here. I want to see it succeed. And all these companies really want, and they're paying us to do that. So I worry about that, but that's the only thing that can, and if we start slipping, like WebKit, or have problems, then yes, I'll worry about that. We haven't been there. I mean, the 20 years we've been doing this, we haven't hit that yet. I hope we don't ever. I want to retire doing this. But actually, people retiring is an interesting group of people because they are now retiring and spending time working on the kernel for fun. I'm getting a lot of ex-Microsoft people retiring and contributing to the kernel. It's fun. I had a neighbor at a place I used to live. My neighbor was an ex-IBM mainframe developer. He got into it because he didn't have anything to do. He was retired. Started contributing to the kernel. It's a nice hobby. So there's a question behind you somewhere. No. Yes, there it is.
Something. Well, how do you think about Taiwanese companies? Why many Taiwanese companies doesn't commit to the Linux kernel? And how do you think about leakage of Samsung's EX FAT driver, which is overheard that Samsung was using the FAT driver, GPU of the FAT driver, and committed to and claimed to have a proprietary driver.
The first one, Taiwanese. So I track companies and I track individuals. I don't track where you live. I just don't know. I'm not going to track. A lot of people thought I used to live in Germany because I had a German email address for many years working for SUSE. The SUSE Novell developers in Taiwan are maintainers of some drivers and some subsystems. They're very, very good developers. Joey, or Al, kernel developer. These people are good kernel developers. There's a lot of other companies here doing kernel work. Some of your wireless chip companies are doing kernel work. They're in the kernel contributors. So Taiwanese are doing great. I don't know who are, if there's somebody I need to talk to do better, please let me know. That's it. So, was there another question? Oh, the Samsung driver. I don't know about that. I haven't seen it. Samsung hasn't sent it to me, so I'm not a lawyer. I'm actually going to go talk to Samsung in a few weeks, so maybe we'll talk about it then. I don't know.
I have two questions. The first one is, you have mentioned that a lot of patches gets accepted every day, but there must also be a lot of patches that's rejected every day. So what are the common mistakes that that gets patches rejected? As in, why do patches get rejected? So that some of the newbie developers here will watch out for these common mistakes so they avoid it when they submit patches to the kernel. And my second question is that, as you can see, most of us here are not developers. Some of us are users, some of us are promoters. So I'm sure there's not just code in the kernel, there are also documentation, translations. So in addition to coding, what other stuff can people here contribute to the kernel? And how can we contribute to the kernel in addition to coding? Thank you.
So I'll do the first one, common mistakes. I gave a whole talk about that last year in Japan. If you go to my GitHub, there's another presentation there that lists all the problems I saw in 2 weeks that was sent to me. And there's the documentation, how-to, points you to the rules on how to do things. So just read the rules, and if you have questions, ask us. But there's a lot of common mistakes, so we've documented those. So I can give a whole talk on that. The second question, what was that? Remind me.
My second question was that in addition to coding.
Oh yes, in addition to coding, yes. So what else can you do if you aren't a developer? You can run it. You can just build the code, run it, and see if it works for your hardware. If not, let us know. That's a huge thing, because we can't really do a regression test for an operating system due to all the different hardware stuff. So just build it, run it. You don't have to be a developer to do that. Documentation, if you find spelling mistakes, literally, people have gone through and cleaned up spelling mistakes in comments. It sounds trivial, and it is, but it makes our code easier to read. The Linux kernel is a very easy code to read, and we want it to be that way. So fix spelling mistakes, it's great. Fix our documentation mistakes. We have tech writers that help us all the time. Help people for promotion-wise. Linux.com has a bunch of things you can do to help promote Linux that you can go look at. And they have contributions and they have conferences you can go to and things like that. So yeah, that's the best thing. But yeah, we'll take documentation back. White space, people clean up white space. That's a good thing. So your brain, white space is important. Common coding styles is important for your brain. You want to see, the brain sees the patterns go away and it can read things easier. I can only do 7,000 patches, accept 7,000 patches a year because of common coding style. So if it's wrong, please fix it. Okay, let me look at the company. So I have a list here. That's right. So Canonical they are number 29 last year. They got 400 patches in. I mean, Canonical's done really good. Canonical's gone high. Canonical doesn't have a lot of kernel developers on staff that are able to do contributing on stream, but they're doing good. I mean, doing 400 patches a year is not trivial. Right? So Canonical's doing well. Canonical's like any other distro in that they spend a lot of time fixing the little problems, getting the laptop buttons to work right, and things like that. So it's a lot of little tiny work. They do have some other developers that are doing bigger features, and they're contributing. So they're good. They're good. And what was the other company? Let me see if I see that. Here they are. Yeah, they did 4 patches last year. I wrote 13 this morning. Who do I need to talk to there? I mean, talk to me afterwards. They need to get better. Yeah. I mean, come on. Anybody here can do white space cleanups for 4 patches. I don't know what they're doing. I honestly don't know. They should do better. your company uses Linux and you're happy with all those companies, how they're doing Linux, great. Fine, you rely on them. If you want to control your own destiny and your own company's destiny, then you need to get involved. It's that simple. If you're gonna trust that Samsung and Intel and IBM and Lenaro are doing best for your company, that's great. But MediaTek sounds like maybe they trust us. Right there. Do two more talk. This one and that one, that's it.
So you have over 7,000 sign off by pages. Do you read each page and try to understand it, or sometimes you just do a very quick sanity check?
The majority I read, and I read it and make sure it looks correct. I have to. That's what I do. So that's the ones accepted. Some I trust from people like Hartley. I take a lot of Hartley's patches, and I'll just glance at them. I'll say, Hartley's good. Because he's been around for a while, right? I trust him that if it's wrong, he'll fix it. And that's a trust relationship there. So, but the majority of people, yeah, I read the code. That's all I do is read code. That's all David Miller does, is read code. It gets boring, it makes us grumpy, it makes us mad sometimes. But that's my job. And there's a question up here. And I think that's the last one. Did somebody have a question?
I sent you some of them.
All right. Anywhere else? Last one. All right.
How do you decide which feature is going to be picked up into the upstream?
Whatever is submitted to me. We don't know. That's the thing. We don't have a roadmap. We don't have a roadmap of what's going to be in the next kernel. It's just whatever you send me. Literally. So if you send it to me and it looks good, great. I'll take it. If you send it to me and it needs work, I won't take it. So, I mean, two examples. I had people send me out of the blue, brand new drivers this past couple days. One of them, yeah, looks good. Took it. One of them, no, needs work. Need to go back and do it. So yeah, it's just that. All right, last one.
I have one question. Where is AMD? AMD is where?
AMD?
Yes.
They are number, yeah, 25. They did 500 patches last year. AMD has done really well. One thing AMD did, they just laid off their kernel team. And they all went to work for Amazon. And that happened a few months ago. So AMD's core kernel team that did KVM development now works for Amazon. So those 500 patches will probably be now soon coming from Amazon. But they have a lot of people. I mean, AMD is huge. But video driver is just a tiny driver. Anyway, thank you very much for inviting me and for having me. Very good.